Let's continue our discussion of multiplication algorithm. So we left off on the lattice methods. Hopefully that makes some sense. There's another way of organizing your multiplication inside the textbook. I'll remind you of interactive links and things. And so um, if you want to practice your lattice method, you have a link there to do that. So it kind of walks you through that process of the lattice method. So we move on to standard algorithm for multiplication. Again, the textbook's going to have a lot more explanation. Of course, I'll do my best in my video to help you with that. And before we actually look at the standard algorithm, we're going to take a look at the intermediate algorithm that is connected to the standard algorithm. Intermediate, again, this in between one that uses distributive property, expanded form, those ideas to give you what we call the partial products algorithm or the intermediate algorithm, where we're going to and then add them up after we do the partial product. So you'll see a lot more inside the textbook, but let's go and take a look at an example before we jump into the standard algorithm. So we have the intermediate algorithm, or again, partial products algorithm. And partial products, because we're doing not the entire product, we're doing it in pieces, as you can see here in both of these examples. They're the same, just done in different order, similar to we had the intermediate algorithm for addition. So it's how you want to see it. Some people see right to left, some people see left to right. Either way is correct. It's just an algorithm. It's a process. What you see, you're going to end up with the same answer, but it's using the partial product. So pause if you need to look at that and take a look. And then let's look at this example of a partial product, 27 times 91. So when we look at those partial products, what we're looking at is each of those individual place values, 27. So in my mind, I know that 27 is 20 plus 7, and 91 is 90 plus 1, right? It's the place value understanding. So those are the key numbers that you're going to get. So we end up with, to get this, it's 7 times 1. To get this, it's 20 times 1. To get this one here, it's 90 times 7. And here it's 90 times 20. So you could see where those numbers are coming from. Technically, I want to say, actually, I should reword this. This is really 1 times 7 and 1 times 20. Either way, it doesn't matter, but starting from the bottom up. And so once we have that, the partial products, then we sum it up, 5, 14, 1, 2. So then that's it. So maybe that's another way to think about it versus think about what the algorithm is, which we'll take a look at it. Same thing. What would the algorithm be? This is where we get these numbers from. So this would give me 32. This would give me 120. This would give me 2000. Notice there's no place values, adding zeros or x's. You just do the math. 240. This would be 9,000. Sorry, 900. I should be able to fix that. That would be 900 there. There we go. It's a little slow. 900 is here. And then this one here is 15, and then 3 zeros. And then you add it up. That's what we get. 2, these are all zeros, right? So no, this was 240, 30 times 8. So 5 plus 4 is 9. 1, 2, 3 plus 9 is 12. 8 and 1. So we end up with 18,292. So we'll take a look at, that's what we should have, 18,292. Yeah, okay. So what does that leave us before we look at division? Well, again, the standard algorithm, which we don't practice a lot because we have that, but again, you can look at the textbook to remind yourselves of that. So let's do that before we look at the standard algorithm for base 5 and base 2. And so looking at the standard algorithm for, let's do the 538 problem, right? 8 times 4 is 32. So you put a 2 and then we add the 3. So 32, and then we're giving it 3 more groups of 10 to 32. You're still going to do 4 times 3 is 12, because now you have 12, 120, and then 3 more 10s, right? But 4 times 3 is 12 plus 3 is 15, and then you do that. 4 times 5 is 20, plus 1 is 21. So again, you could kind of see that we're just following algorithm. Students may not know what to do, or what do I add? Where do I put the numbers? So it becomes, and then you have to do a place value because we're going to multiply by 3, but we really multiply by 30, so that's why you have a 0. 3 times 8 is 24, but you can start to see it's hard to accumulate all the numbers. 3 times 3 is 9, plus 2 is 11. Put another 1. So you can see it's hard to keep track of everything. 3 times 5 is 15, plus 1 is 16. So then we have that. So you can see where students will get a sense, I'm not sure what I'm multiplying, right? And so that's why the move to the intermediate makes some sense. I now see what I'm multiplying to get the numbers. Of course, the intermediate is a little bit more steps, but does it make more sense? That's something you need to think about. So let's go ahead. You have the Wonder Play Grow. I want you to practice the base 5, right, and base 2. So you have those examples there that are completed, but now this requires understanding of base 5 single-digit multiplication, right? And so you see over here, we could solve them different methods, standard algorithm, lattice method. So again, this is not a key component, a big idea, but it's important for you in the learning of it. And so trying to think through like a student would, I think is essential to your understanding, right? As we do some of these problems here, and I've done them different ways, but again, for you to be successful, we need to remember the base 5 and base 2 arithmetic in order to figure that out, right? And so in base 5, sorry for that, base 5, 3 times 2, this is base 5, equals 6, but that would be 1, 1, right? So that's the type of stuff we need to remember. That's 16, but that would be 3, 1 in base 5, right? Those are base 5 numbers. So that's the type of arithmetic we need to remember. 4 times 2 is 8, but that's 1, 3 in base 5. How about in base 2? Well, it's a little bit easier because everything's 1s and 0s. So 1 times 1 is 1, 1 times 0 is 0. So it's easier to navigate that arithmetic. You just got to remember the adding part. So hopefully you can get through that. Use my example there to support you.